All right, let's just jump right into it. Today, we're unpacking the story of the quiet, unseen engine behind literally every major AI breakthrough we're seeing right now. From ChatGPT to modern medical research, there's this one foundational layer powering the whole shebang. We're going to look at how a company that used to just build chips for PC gamers quietly built what's probably the most strategically important business on Earth. You know, the 19th century California gold rush actually perfectly mirrors today's AI boom. Back then, all those prospectors were gambling on finding treasure, right? But the suppliers, the folks selling the shovels and the tents, they made money no matter who actually struck gold. Well, NVIDIA has basically positioned itself as the ultimate shovel seller of the AI age. Every tech giant out there wants to build the next revolutionary AI model, but to pull that off, they absolutely need the computational shovels that only NVIDIA provides. Section 1. Before NVIDIA, the bottleneck. So back in the early 90s, personal computers relied entirely on the CPU. Think of a CPU kind of like a single, incredibly talented master chef, making every dish one by one. It's super versatile, but it gets overwhelmed really quickly by sheer volume. And early 3D video games demanded millions of simultaneous calculations just for lighting and textures. The solution? The GPU. Instead of one master chef, a GPU acts like thousands of specialized workers tackling all those simple tasks at the exact same time. And that brings us to 1993. That's when three engineers, Jensen Huang, Chris Malachowski, and Curtis Preem, founded NVIDIA. They made a massive, really bold bet that this kind of parallel graphics processing was going to be the future of computing. And man, it wasn't an easy road. They burned through a ton of cash, and their early chips completely failed commercially. But Huang, who was shaped by a childhood that really taught him resilience, he built this culture of relentless innovation that kept them pushing forward. Laying the groundwork for an AI explosion absolutely did not happen overnight. It was the slow, step-by-step 30-year evolution of seemingly disconnected milestones. It took an unbelievable amount of strategic patience. Section 2. The Gaming Revolution. Funding the Future. In 1999, NVIDIA drops the GeForce 256. They marketed it as the world's first true GPU, and that permanently cemented the term into our vocabulary. Throughout the fierce tech battles of the early 2000s, millions of PC gamers who were just eagerly chasing better frame rates were completely unknowingly injecting billions of dollars into NVIDIA's R&D. Basically, gamers were quietly funding the exact hardware that would eventually power AI. Section 3. The Secret Bet. CUDA. Then, the real game changer hit in 2006 with the launch of a software ecosystem called CUDA. Okay, think of CUDA like owning a massive fleet of delivery bicycles that you only use for food delivery. That's your basic graphics rendering. But suddenly, you unlock that exact same fleet to deliver medicine, books, and emergency supplies. That's what CUDA did. It allowed developers to use GPUs for general-purpose scientific computing, not just graphics. NVIDIA essentially kicked the door wide open to entirely new markets. And this leap in general computing perfectly set the stage for what was coming. Machine learning, specifically deep learning, requires training artificial neural networks through just massive amounts of repeated mathematical operations. Doing that on a standard CPU is painstakingly slow. But as it turns out, it's an absolutely perfect match for the parallel processing architecture of a GPU. This theory was spectacularly proven back in 2012. A couple of researchers, Alex Krzyzewski and Jeffrey Hinton, actually used NVIDIA GPUs to train their AlexNet neural network for a big image recognition competition. And their models so dramatically outperformed everything else out there that it sent a literal shockwave through the tech community. Almost overnight, years of speculative investment in CUDA paid off, creating this locked-in ecosystem that was totally optimized for NVIDIA hardware. Section 4. The AI Explosion. ChatGPT and beyond. Let's fast forward to November 2022. OpenAI launches ChatGPT, and it just kicks off this global, industrial-scale engineering race. Training these massive language models require tens of thousands of advanced GPUs all working together. With cloud providers and startups literally fighting over scarce supply, getting your hands on GPUs became a bigger hurdle than raising the money to buy them. Which brings us to a massive economic question. What is an infrastructural monopoly like that actually worth? Well, the answer is staggering. Driven by incredible pricing power and just off-the-charts demand, NVIDIA's revenue skyrocketed from roughly $61 billion to over $130 billion in a single fiscal year. Net income surged right along with it.
They weren't selling the finished AI products, they were supplying the factories to build them, and customers were more than willing to wait and pay whatever it took.
This kind of unprecedented growth is being fueled by massive capital expenditures from tech giants. We're talking hyperscalers like Microsoft, Meta, Google, and Amazon pouring tens of billions of dollars into AI data centers. It creates this powerful economic feedback loop, right? More AI demand leads to more infrastructure investment, which funnels straight back into demand for NVIDIA's products.
Section 5. The threats on the horizon. But no tech monopoly is untouchable forever, and NVIDIA does face some very real threats on the horizon. First up, AMD is investing heavily to close the hardware performance gap. Second, major clients like Google and Amazon are actively building their own custom silicon, so they don't have to rely on NVIDIA so much. Third, their manufacturing is precariously tied to just one company, TSMC in Taiwan, which raises some serious supply chain concerns. And finally, shifting geopolitical export restrictions heavily dictate where and what NVIDIA is actually legally allowed to sell. Beyond just the hardware, there's also a fierce, ongoing debate on Wall Street about NVIDIA's massive valuation. On one hand, investors argue that AI is going to permanently transform every single industry, which easily justifies today's enormous spending. But on the other hand, there's the risk that markets are just riding a wave of overly optimistic technological hype, and that the demand is eventually going to cool off. The facts are measurable, but the future? Not so much.
Section 6. Accelerated Computing, the Next Era. Looking past today's hype cycle, CEO Jensen Huang argues that AI actually isn't the final destination. It's just one application of a much broader shift. Basic computing problems have simply gotten too large for traditional processors. So while NVIDIA is leading the pack right now, the future is absolutely going to bring new architectures. Things like photonic processors, neuromorphic computing, and quantum computing are all in active research right now. Eventually, they could complement GPUs or maybe even challenge their dominance entirely. Yet, regardless of what tomorrow brings, NVIDIA's legacy is pretty much already cemented. Much like the unseen railroads and electrical grids of past centuries, NVIDIA spent decades quietly building the foundational infrastructure that society suddenly realized it couldn't live without. They didn't build the smartphone, the internet, or the chatbot. They just made the future possible. So as we look toward a fast-approaching future filled with autonomous robots and staggering medical breakthroughs, I'll leave you with this one defining question to think about. Years from now, historians might debate who built the smartest AI, but there will be no debate over who built the machines that allowed intelligence itself to scale. Thanks for joining me for this explainer, and keep questioning the technology that powers our world.